This video I just want to make a quick example of how to solve an algebraic or two linear equations simultaneously with a graph. Now it is actually the easiest way to solve them rather than the algebraic way, although students seem to understand the algebraic way better because there are steps involved. Now here, yes it is, all you need to understand is that this is a line. That is a straight line on a graph. And so in order to draw a straight line on a graph, all I need to do is find 2 points and connect those 2 points. So for example, if x is equal to 1, then we have negative 1 plus 4y equals to negative 1. So x is equal to 1. That means we're somewhere on this line. X is 1 everywhere on that line. Now we're just trying to find out what must y be. So we get 4y is equal to, and then the negative 1 plus on both sides gives me 0, so y is equal to 0. So when x is equal to 1, y is equal to 0. So that gives me my first point. X is 1 and y is equal to 0. Now for the next point, I'm going to just use another point for the same line. So I can use, for example, x is equal to 5. I'll show you now why I'm choosing x equal to 5. 5, if x is equal to 5, I get negative 5 plus 4y is equal to negative 1. And so I get 4y is equal to 4, so y is equal to 1. Can you see why I chose 5? Because now I just simplified this calculation. When I put in a negative 5, when the negative 5 was added to the other side, okay, that made it a positive 4. So it was just easy to solve. But you could have used any number, really. I was just able to predict a number that will give me a prettier solution. So when x is equal to 5, so where's x equal to 5? There it is. Then y is equal to 1. There we go. And so here what I have is I have 2 points. I can choose another point, and you'll notice I'm going to draw a line through those 2 points. Okay, here's a line through those 2 points. And I'm just going to stretch it this way. So there is my linear, the graph. Now look, if I chose any other number. So for example, if I chose the number 9, 9 will again give me just a prettier solution. But again, you could choose any number. Then I choose that. Then we get negative 9, choose that, negative 9 plus 4y is equal to negative 1, and so we get 4y is equal to 8, and so y is equal to 2. Okay, so in other words, when x is equal to 9, y is equal to 2. Now look at that. When x is equal to 9, y is equal to 2. And that's the whole point. You could have used any points and it would have given you a point that's on this line. Okay, if I do now the same thing for this other line, 2x minus 4y, let's choose it for y this time. It doesn't matter which one you choose, so let's choose for y this time. We're going to make this one equal to 0, so we get 2x minus 4 times 0 is equal to negative 2. So we get 2x is equal to negative 2, which means x is equal to negative 1. So when y is 0, that's here on the x-axis, then x is equal to negative 1. And then if we choose another number, again, let's choose a number that will, any number will work this time, but let's choose, for example, 1. So we have 2x minus 4 is equal to negative 2. So 2x is equal to 2, x is equal to 1. So when y is 1, x is also equal to 1. Y is 1, x is equal to 1. So that line, and if I draw a straight line through there, you'll now notice, let's see, make it a bit thinner. I can't make this one thinner anymore, but you'll notice now what happens is that this point here, okay, again, you could have chosen any point, you would have made the exact same line. Now you notice that where these two graphs intersect each other, there at that point, that's where they intersect each other, that is the solution. In other words, that's the solution, that's the point that you can substitute into both these equations and it will be true. So for example, if I chose this point, you know this point that I got here? That was the point x is 9 and y is equal to, what was it, 2. Now that solved this equation. So for example, when x was 9, negative 9 plus 4 times 2, so negative 9 plus 8 is equal to negative 1. It worked. But if we chose the exact same values and we tried it in the second equation, it wouldn't have worked. So for example, 2 times 9 minus 4 times 2, what does that give me? That gives me 18 minus 8 is 10. And I want it to be negative 2. So this point doesn't work to solve both equations. But this point will work to solve both equations. Let's see. It's the solution. X is equal to negative 3. Y is equal to negative 1. Let's see. Negative times negative 3 is positive 3. Plus 4 times negative 1 is negative 4. So we get 3 minus 4 is equal to negative 1. It looks like a negative 7. Negative 1. That works. Okay, how about the second one? 2 times, now, negative 3 is negative 6. Minus 4 times negative 1 is plus. So we get negative 6 plus 4 is equal to negative 2. It works. It works for both of these equations. It's the only point that will work for both of the equations. So what's the aim of solving an equation algebraically? Well, then you just use algebra methods. You maybe add these two together, and in this case it's easy. You add them together and then you find an answer for x, substitute x, get an answer for y. What does it mean to do it graphically? Forgot that word for a moment. How do we do it graphically? Well, we draw the graphs. This is a straight line, draw the graph. That is a straight line, draw the graph. Where do these two graphs intersect? That is the solution. So it is actually very simple to understand, very simple to apply, but maybe a little bit more difficult to understand than the mindless method of the algebraic solution. So try it, use it, and definitely make sure you understand this concept. This concept will repeat itself over and over, that the solution of where two graphs are equal at the same time is where they intersect each other. So when are these two true at the same time? Well, where they intersect. Draw them and find the point of intersection. Thank you for watching. Hope this helped you a little bit.